Welcome, 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 welcome. Today we talk about classes and objects. This will be our introduction into object-oriented programming. And you might say, wait, isn't this a C++ concept? And yes, you're right. But today we learn how to implement classes in plain, good old C language. This is really cool. And we just jump right in. So I prepared my stupid function here. It's called my function again. It expects two integers and returns an integer. And it also prints out my function called and the parameters it was handed over. Okay, so far so good. So first thing we got to learn, I have to prepare this a bit. So we got to learn two things. So first thing we got to learn is functions are types. And you might say, this is crazy. This is weird. Integers are types. We're all used to this, but functions, what does it even mean? So we can answer all those questions for functions like we can answer them for integers. So it's like this old rule: when it walks like a duck, when it quacks like a duck, when it looks like a duck, it's probably a duck. So because we can answer all those questions for functions, it means it's a type. And we cannot answer those questions for apples or for, I don't know, for anything you can come up with because it doesn't even make any sense. Yeah? But for functions, it makes sense. So what's the size in memory of a function? Yeah, it depends on the code. Yeah, a long function has a big size. So, but compiler knows. That's important. Memory layout, compiler knows. Bit interpretation, C code. Allowed operations? Not so easy. Does it make sense to add functions? What does it even mean? What does it mean to add two functions or to divide them? It doesn't make sense, right? So this is not so easy to answer, but there are operations we can do on functions. Like we can call them, like my function. Yeah, so we can also make something like this assignment operator. So system 5. How do we hand over a function to a function? This sounds weird, but we do this with pointers and we learn that later. Alignment, so all data types inside a function have to be aligned according to their size. To be the starting address of each variable must be divisible by its size, right? So you know what I mean. Okay, so far so good. So so can we do something like this here? Integer x is my function. So this doesn't make sense, right? So it's just the wrong type. So integer is 4 bytes. My function is some size, and when the compiler is instructed to assign my function to x, what does it even mean? It's 1,500 bytes or so, or any number, and has very different operations. What does it mean? Yeah, we don't know. Yeah, so it creates an error. So here on the right, we can see it. So it says, yeah, it doesn't make sense, basically. So it doesn't know what to do with it. So we just have those simple variable types, yeah, and it doesn't qualify for a function, but we can do something different. We can a pointer to a function. We just can point to the address in memory of this function. But what type is it? Yeah, the compiler knows, has to know. Oh. So there's this syntax in the C language. So the way we write things, that's a syntax. And we just need to hand over the structure of this function call. So it expects two parameters and returns one. So we write down the stuff exactly like above, without variable names. Remember, variable names are just an illusion for us to create better code and make it more readable. The machine doesn't know variable names, and the compiler doesn't care either. So it just needs to know what the structure of our function is. Okay. So this is already valid C code. So we can compile this. Works. And now I just defined two variables like integer and so we have two variables now. It's just a short way of writing it down. And n shall be my function, let's say 2 and 3. So remember this print statement. So this should be called now. M is, and now here it comes, pf, let's say 4 and 5. So we can also print out those variables. So now you see, when I this command executes my function with these parameters, and also this calls my function. So it's basically an alias for my function. So is it of any use? Does it make sense? Yes, it does. We will see shortly. Okay, so far so good. So now we understand that we can use pointers and assign functions to them. So step 2, struct. Struct is a compound data type we define. So it's my data type, like so. And in this cases, the bracket must end with a semicolon. I know in the past I said braces. I know it's wrong. It's brackets. Okay. Integer. Let's say now we define our data type, and we can just say integer a, integer b, and we also can define the text. So it consists of several simple data types. So we have to explicitly define the size here because the compiler has to know. But there's one exception. We actually can define variable text size here if it's the last variable of the struct. Then it can be of variable size, and the struct can be of variable size. But we have to allocate the memory dynamically, and what that means we learn much later. So we don't care for that. No. Okay, cool. So we have this data type, and now let's talk about structs. So type struct. So we talked about function. Now let's talk about type struct. So it has 4 bytes, and 50 bytes. So it's 58 bytes. Now you see why it's a user-defined data type. Because, let me do one thing more. We define a variable with this data type like we would do it with any other data type. We can call it now G. G is a variable now. And we can access members of our data type by just using the dot operator. G.A is, let's say, 25. So don't get irritated by this here. This is just syntax. This is like writing integer G. Yeah, you might be irritated because we defined it and it's 2 words, but actually it's just syntax. Yeah, this entire thing here is one type, and one type only. That's all it is. So we can now print out G.A here like a normal variable and say G.A. Oh, typing error. And now we see GA is 25. GA is 25 works. Nice. Okay. So we think about this thing as a data type because we have this one variable and this one variable only to access this entire complexity here, whatever we write down here, all those variables here. So it really makes sense to think of it as one single data type and see it the same way. And that's why the way we defined it, it's 58 bytes. the memory layout is, and this is very interesting, it's one byte after another. So first, at the starting address, we have 4 bytes of int, exactly how we defined it, 4 bytes of int. Then this is exactly what we defined. When we change the order, this order will change too. This is very important because then we can run through such structs with pointers very fast. That's really cool. Okay, so the bit interpretation is integer, and then char50, right? That's how we interpret those bits. I know in the past I often said bits and bytes, but actually the correct word is bit interpretation, I would say, because like an unsigned int and an integer, they differentiate each other only by the interpretation of the 32nd bit. And in case of an integer, it just defines the, whether it's plus or negative. So I think the correct word is here is bit interpretation. So allowed functions on struct is, we've seen the dot operator, but there's also this operator. Come to that later. How to hand over a struct, usually it's done by pointers. But there's one notable case, the return value, when it's when it consists of, let's say, 2 integers, it's actually returned not by pointer, but in the registers, so by copy. But this is mesh and code stuff. It's so important right now. Okay. So this is a data type. Now we bring it all together. Now we build a class. And therefore, we rename this thing here as class. This is going to be our class. Class G. And now we copy. Let's call it head. Copy our pointer inside here. So let's, I don't know, let's delete all this stuff here. My object. Okay, so now we can again just assign values to my object. But we also can assign a function to this object. So you see it's a data structure, but now we have a reference to a function inside. And that's what classes are, right? It's a combination of data and function, right? Is it? We learn that soon. So struct my class, my object. So we can now just call, we can define a variable. Let's say integer var, and var shall be my object dot add. And we can hand over values like 5 and 6, and then print out var. Whoops, this shall be it. So you see my function gets called. My function gets called, and variable var is 11. So this is correct. So now we can access functions like we can access normal variables, and this is very close to a class, right? So let's get a bit closer. So writing struct class is, yeah, we can define an alias for that. We can just write typedef. Typedef struct class shall be named in future as just class. So we replace struct class with the word class. We replace struct class with class. Works. That's cool, right? So we can define classes. We have data and we have functions. We don't have this, we cannot distinguish between private and public. But this is just a start. So this is the first video into object-oriented programming with C. I hope you enjoyed it. Stay awesome. See you next time.